Hello everyone, welcome to the session. So until so far we have seen that what is array data structure and how we can do the implementation in Python on the basis of array based data structure. Now I think it's the right time to go deep dive into it. So whenever we are talking about arrays, we have 1D array, we have 2D array, 3D and so on. The question is that what is the major difference between all these kinds of arrays? So whenever we are talking about one-dimensional array, whatever examples I have showed you in the previous examples, in the previous videos, all are based on one-dimensional array only. We are having only one dimension. Name suggests, right? Only one dimension is there. So suppose I have created one array which contains maybe the elements like 2, 4, 6, 8, 12, 15, 20, 27, 37, like that. So here we have seen that, for example, if this is the array that we have, okay, so in this particular case, we are having 0 as a by default index, then 1, 2, 3, 4, 5, 6, 7 and 8. So here we are having the elements starting from 0 until the value 8. So these are the indexes that we have in our array, correct? Now, this is a kind of a one-dimensional array, and here we all know that random access is also possible. Here, whenever we are talking about contiguous based, that also we have discussed that, for example, here suppose I am assuming that the memory address is 1000. So the starting address of an array, so this is an array that you have where this is the starting address which is 1000, is also known as a base address that everyone should know. Now on the basis of this base address, you can calculate the address of any of the element which is present in this one-dimensional array. This is called as a 1D array. So I can say that whatever examples I have taught you in previous videos and now also is an example of 1D array. Here, given a base address, you can access the address of any of the element. You should also know that what kind of elements are stored inside your array. For example, I am saying that there is integer type elements which are containing 4 bytes of data. Okay. So in that particular case, suppose I am telling you that, can you tell me that what is the address of AR of 6? Can you tell me what is the address of AR of 6? One way you can do manually, that you will add +4 at each and every time. You will say 1004, then you will say 1008, and you will keep on adding +4 until this particular portion you will reach. Another way, what you can do is that you will try to access this base address which is 1000, plus you will say to me that which particular address location I want, what is the index number, 6. Minus from where I am starting. By default it will start from 0. By default it will start from 0, which is the lower bound, multiplied with what is the size of each element that we have. For example, here I am saying it's 4, right? So this is nothing but you can clearly say to me that this is 1000 plus 24, which is equals to 1024, because of the property of contiguous storage of an array elements, because here we are storing the elements in the array in a contiguous fashion. Contiguous storage of an array elements, right? This is the way where we will be easily access any of the memory address given the base address, given the bytes it is taking for each element. So in general, we can easily able to access the value of AR of I, memory address I am talking about, right? So this is the simplest formula that we have, which is equals to what is the base address of an array. What is base address? The starting address of an array element, plus what is the value of I minus what is the lower bound of an index? What is the lower bound of an index? Simple. By default it will be 0, but in an MCQ, if suppose you're going for an interview and you are having some MCQ based problems, in that they have changed the lower bound and they are saying that the index is starting from -1, or the index is starting from -2, or the index is starting from 7. So accordingly you have to choose your lower bound. Your lower bound by default, I will say, in an array will be 0, but they can manipulate the question just to make a confusion to you, just to see you that is your fundamentals are clear or not, right? By default, the lower bound or the index value will always start from 0. Into what is the size of an array element? Size of an element. So it can be 4, it can be 8, depending upon what kind of elements we are trying to store. For example, if we are storing the elements of multiple types, then in that particular case, we need to see, right, at each and every time, which is the, what particular character or float or double or integer we are storing. Accordingly, we will calculate the address of the memory. But here, if it's of same type, this is the valid formula that we can use to access the address of any element. Okay, this is fine. But is this the only kind of array that we have? No. Usually, we have another very important type which is quite frequently used in practical real life situations as well, named as 2D array. As the name suggests, whenever we are saying 2D array, it means that it is composed of rows and columns. For example, today whatsoever be the matrix calculations or the matrix computations that is performing automatically, algorithmically, is only done with the help of this 2D array, right? If the matrix is 2 dimensions, right? So here, whenever we are saying 2D array, simply means that we are having the row number and the column number. For example, here I am writing 2, 4, 6, 8, 10, 12, 14, 17 and 20. For example, this is a kind of a 2D array that I have, right? This is a kind of a 2D array that I have here. So here, if you will try to see what is the row number, this is a row number, right? These are the rows. Means 2, 4, 6 is one row, 8, 10, 12 is another row, 14, 17, 20 is another row. By default, again, as I stated you in the 1D array, that index will start from 0. Similarly, in 2D array, by default, the row index and the column index will start from 0. Again, this is a very important point to take care of. So by default, it will start from 0, then 1, then 2. So here, this side, when I am mentioning 0, 1, 2, these are the row indexes. Column indexes are again, this is 0, this is 1, and this is 2. Simple. So these are simply the columns that we have, and these are simply the rows that we have. So here, column wise, if I will write the matrix, so it will be like 2, 8, 14 is the first column. 4, 10, 17 is the another column. 6, 12, 20 is the another column that we have. So these are the columns that are given to us. 3 columns, 0, 1 and 2. Similarly, if I will talk about rows, row wise it is 2, 4, 6. Then comes 8, 10, 12. And then comes 14, 17, 20. So these are the rows that we have. These are the rows that we have. First row, second row, and the third row. 0, 1, and 2. Right? So now this is a 2D array that we have. Again, the property of an array will remain same. What is the property? The property is that a random access is allowed. That by giving the index numbers, we can access any sort of element that we have. This is what we know. Now, here if you will try to see, so in the above case, we all know that how the random access will be implemented. For example, if I want to access 20, I simply mention what is the index number? I will say 6, and it will simply return to me the value as 20. But now here if you will try to see, in this particular case, how we can simply access any element, whatever we want. That is with the help of a row number and the column number. For example, in this case, if suppose you want to access this 20 number, you will mention what is the name of your array. So name is array, suppose. Then you will have to mention in these two boxes, what is the row number and what is the column number. For example, here we can clearly see that the row number corresponding to this 20 is 2 and the column number corresponding to 20 is 2. So we are saying that go to first of all the row number 2 and then the column number 2. So it will directly jump and will give us the value as 20 here. Similarly, suppose if I want to access maybe 4. So what is the way to access this element? Again, you will mention what is your array name. You will mention what is the row number. You will say it is 0. What is the column number? You will say it is 1. And this is how basically you will be able to access any sort of element that you have in a 2D array. Now, usually whenever we are seeing visually, this is a kind of a form which we know. But internally, memory usually represents these 2D array also in the form of a 1D array. That is, either it is based on a row major form or it is based on a column major form. These are the two important forms that we have, with the help of which our memory stores the array elements in the form of a 1D array, even though it seems that it's a 2D array that we have. When I am saying row major form, it means that row-wise elements are stored in the array. When I am saying column major form, it means that column-wise the elements are stored inside the array. Row-wise meaning that first of all, so here in total we are having 9 elements. So when I am saying row major form, what will happen is that indexes will be, first of all, we will create the array here, and here 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here what will happen is that row wise we are storing the elements of the array. Means 2, 4, 6 will be stored first. After that 8, 10, 12 will store next. And after that 14, 17 and 20 will be stored next. And it's a 9 element, so our indexes should also be from 0 to 8, right? Then only we will be having in total 9 elements. Now it is fine. So this is something which we are saying in terms of DS called as row major form. And by default in various languages, this form is the one which is acceptable. This is the only form by default until or unless you are not defining anything. The elements are stored in a row major form inside the memory location. But when you are saying column major form, with which also we can store the array elements, so in that case, what will happen is that column wise elements will be stored. For example, here I am saying 2, 8, then 14 for first column. Second column will be having 4, 10 and 17, 4, 10 and 17. Third column we will be having 6, 12 and 20. So this is how basically in a column major form elements will be stored. Where when we are talking about column major form, it means that column wise we are storing all the elements inside the array. So usually in the visual manner, this is the form that we have, but inside the memory there is nothing called 2D. There is always 1D, where the elements are either stored in row major form or in column major form. Now the next question came in our head is that okay, we have seen that how the memory address will be formed up whenever we are talking about 1D array. But what happened when we are talking about 2D array? Suppose I want to see, so here also we have a concept of base address. Suppose the base address is 1000, and suppose I want to see that what is the address of this element 17. Then how we can do so? I think this thing, that whatever question I have asked you, just try to think over it. Just try to see whether you can form some formula for that, just like the way we did above. In the next video, I'll talk about this particular case only in much depth. Till then, take your time, try to see whatever things I have covered up here is clear to you or not. After that, once it is clear, try to see that if suppose the base address is 1000 and I want to check that what is the address of this 17 element that I have inside my memory, how we can do so, just like the way I showed you in the 1D array case. Let's see who will be able to give me the correct result. So you will get a different formula for a row major and a column major form. Try to get just for a row major form. Column major form is very simple. Just you have to interchange the values of I and j, whatever you are picking. So here I am referring as the row index. You can also use that. And j I am referring as the column index. With the help of which, are you able to create some general formula which is basically helpful for me to get the memory address of any of the element present in 2D array. Let's see who all will be able to get. With this, happy learning to all. Bye bye everyone. See you soon in the next upcoming session.